All right, today we're going to talk about reinforcing some ideas from chapter 1 that we're going to need in continuing our discussion on proofs. So we're going to continue with some more geometric proofs, working with angles and segments, kind of like we did in the last section. And so one of the first things we want to kind of reintroduce and reinforce is this vertical angles theorem. So we talked back in chapter 1 about what vertical angles were. We talked about the special property and that the vertical angles are always congruent. So if you can look at a picture and identify vertical angles, you know those angles are going to be congruent. So for instance, on the picture here, there are two angles already marked, angle 1 and angle 3. Those would be considered vertical angles, and the little markings tell us that angle 1 is congruent to angle 3. Now we also have another set of vertical angles in the picture here in angle 4 and angle 2. Now they don't give us the markings for angle 2 and angle 4, but this theorem tells us that because angle 2 and angle 4 are vertical angles, angle 2 and angle 4 must be congruent to each other. So anytime you see vertical angles in a picture, you can make those angles equal to each other by this vertical angles theorem. The next piece here is kind of a new idea. It's one it's fairly intuitive, but at the same time, it's one that we're not going to use a whole lot over the course of the chapter here, but it is something you might see. So the congruent supplement theorem simply says if there are two angles that are supplements, and remember supplements means add to 180. So if I have two angles that add to 180 with the same angle, then the two angles must be congruent to each other. So if I have two angles, like down in the picture here, angle 1 here and angle 3 here, if they both add up to 180 with angle 2, then angle 1 and angle 3 have to be congruent to each other. And that should make sense because let's say angle 2 is 150 degrees. Well, if I know that angle 1 adds up to 180 with that, that means angle 1 has to be 30. But then if I also know angle 3 adds up to 180 with angle 2, then that must also be 30. And we can see that those two angles end up being the same. So anytime you find two angles that are supplementary, they add up to 180 with the same angle, you have congruent angles. They have to be the same so that they can add up to 180 with both. Same thing with congruent complements. So this is another one we use here and there, but it's not like the most important theorem we're going to talk about today. And this one talks about if two angles are complements. And if we remember back from chapter 1, complement means add to 90. So if I have two angles that are complements of the same angle, then those two angles must be congruent. So again, we look down at the picture here. Angles 4 and 5 are complementary, and we get that because of the little box right here telling us that's a right angle. But then they're also telling us angle 4 and angle 6 are complementary. So that means angle 4 and 6 have to add up to 90 as well. Well, so if I think about this, let's say angle 4 is 50 degrees. Well, 4 and 5 were complementary. That means angle 5 has to be 40. And then if angle 4 and angle 6 are complementary, that means angle 6 must be 40 because they have to add up to 90. Well, so then we can see those two angles have to be identical to each other. So angle 5 would be congruent to angle 6 because they're both complementary to 4. So supplements or complements doesn't matter. If I have two angles that are the same to 1, then those two angles are going to be the same. This next one's pretty straightforward. Right angles are always 90 degrees. So when we have right angles, we know that all right angles are congruent to each other. So no matter where I draw my right angles, no matter how I draw my right angles, okay, as soon as I know it's a right angle, that means that's 90, that's 90, that's 90. All right angles are going to be congruent. So in a given picture, if you see multiple right angles, you know all of those right angles have to be exactly the same measure. They always have to equal 90. Just some review of some topics, again, from chapter 1, kind of working with the reinforcement idea here. Given pictures like this, being able to solve for x. So like over here, we see this 3x minus 14 and this 2x plus 10. Well, we just discussed earlier in the slides that these angles would be considered vertical angles, and so 3x minus 14 has to equal 2x plus 10. And we know that because they're vertical angles. And then we can solve the equation, so subtract the 2x over and then add the 14 to both sides, x would equal 24. In the second example here, this is something we talked a little bit about in chapter 1, but again, it kind of reintroduces itself here. Notice on the left side, I have this right angle box. Now, anytime you see a picture like this where you have a right angle on one side and we have a straight line all the way across it, that means the other side also has to be a right angle, which means my two angles here have to be complementary. They have to add up to 90. So I would have 2x plus 4x equals 90, and then I solve. So combining like terms, 6x equals 90, x would equal 15. In that third example, this is something we talked a lot about back in chapter 1, so these showed up a lot of times, and that is we form this perfectly straight line, which means we have a linear pair. That means these angles add up to 180 total degrees. So I can take my 5x plus 5 plus my 2x, set it equal to 180, and then I can go about solving for x. So I can combine like terms, 7x plus 5 equals 180, subtract the 5, divide by 7, and you get your value for x. So recognizing these relationships is going to be an extremely important part of this section. Recognizing vertical angles, recognizing complementary, recognizing supplementary. So being able to know when to use each of those different properties. All right, if we get to some proofs then. So using some of these ideas, so some of the stuff from chapter 1, some of the stuff we've introduced in the past couple of sections, we get proofs that might look something like this. So as we're looking at the picture here, so we're working with angles, one of the first things we should always note in a proof is what's given to us. So they're telling us that the measure of angle 1 is equal to the measure of angle 3. Now, regardless of what the proof is asking for, that always becomes our first step then. So my first step is measure of angle 1 equals measure of angle 3 because it's given. And then I would always make sure that the picture is marked with any given information. So they already kind of marked it for us, but angle 1 and angle 3 are the same. Now, if you look at the next step, this is introducing or reintroducing an idea from chapter 1, which is angle addition postulate. They're saying if I take angle 2 here and add it to angle 3 here, I get this entire angle, which they call angle EBA. So that's what we're looking at right here. This angle EBA is angle 2 plus angle 3. Now, if we look at the next step, so as we follow this proof then, we had this statement, EBA is 2 plus 3. Notice in the third step, we have the measure of angle EBA is equal to the measure of angle 2 plus the measure of angle 1. So we got to think to ourselves, well, what happened here? Well, we had angle 3, and then we took angle 3 and replaced it with angle 1 because of this given information up here. Anytime I see angle 3, I can replace it with angle 1. And if I use one thing to replace another, that's my substitution property. So I replaced angle 3 with angle 1. Now, the next thing I would look at here is they're asking us to come back up into the picture and use angle addition postulate again. So with this angle addition postulate, now we're talking angle 2 and angle 1. So if I put angle 2 and angle 1 together, I'm going to form this big angle here. So we just need to figure out, well, how do we name that angle? So if I trace my letters, starting here, I'd go from C to B to D. So I'm going to get the measure of angle CBD. That was using angle addition postulate. And now if we look at what we were supposed to prove, EBA was equal to CBD. Well, we introduced EBA right away. Now we just found a statement that introduces us to CBD. So now we have both angles we want to have. We need to look to see if we can put them together. So now notice, in our third statement, EBA was 2 plus 1, and then 2 plus 1 equals CBD. So by the transitive property, I know EBA has to equal CBD because I had EBA lead to 2 plus 1, 2 plus 1 led to CBD, so EBD can go straight to it. So that would be our transitive property that we learned a couple sections ago in chapter 2. Okay, so when you're looking at these proofs, make sure you write your given, make sure you look at what you're trying to prove so you know what you're kind of trying to get towards, And then make sure you have the picture marked as you go. So always mark pictures as much as you can to kind of help you through the process. If we take a look at a segment proof here, so in this segment proof, they tell us that B is the midpoint of AC, C is the midpoint of BD. We want to prove AB equals CD. So we're trying to prove, I'm going to put this in purple, so we don't know this yet, but I want to show that this and this are the same. So I want to show that those two pieces are exactly the same. So my first statement is the given. B is the midpoint of AC. C is the midpoint of BD. And that was given to us. So then the next thing we want to do is start to try to get segments equal to each other. I want to show that AB is equal to CD, so let's start looking at what this means. So because it's a midpoint, so because B is a midpoint, that means AB and BC have to be identical. And that's the definition of a midpoint. For the next step, I can say then, because C is a midpoint, I can say BC and CD are the same. Again, definition of midpoint. And then my last step, AB led to BC, BC led to CD, so AB equals CD by transitive. And so with this, you should be able to work on the worksheet for today. If you have questions, ask in class, ask through email, whatever you need to do. But this should lead you into what you are needing to do for this homework assignment to lead to the quiz coming up later. So if you have any questions, make sure to let us know.